Okay, I think you have seen in the previous demonstration, we were trying to emphasize that what you are seeing here is a replica of the sketches or your dream that you put on paper prior to modeling. You understand that bridge, you understand the geometry, the thickness, everything. You do even what we call the preliminary concept. Even the thickness you are trying to guess here. It has to be something that is more like rule of thumb or something similar to your experience on things you've already done elsewhere. And so you're able to do that. So this is the model. This was already modeled it, but for just for knowledge sharing, just you come now. Once you have done all that, you make sure the materials you have your materials are all in place. You specify your materials. You come here. You go to concrete. You come. You can. The standards are all given here. You can do Indian standard, you can do Japanese, you do Korea, you can do British, you can do Eurocode, and then the concrete strength. This is basically the cylinder strength versus the cube strength. Compressive and cylinder is if it is C8 stroke 10, 8 is our cylinder and 10 is the compressive, or yeah, the compressive stuff. So that is what you need to do. Once you have done that, then you come to sections. So in the section, I think here I had indicated that I would model using pile, but I realized for time purposes I left it. We are going to view to see another model where we use the piling. So here it is spread footing, so this section doesn't apply. Since this is a plate, so I do thickness. So for the thickness, you come thickness. You have to come and then they are all here. You specify. You need to know. That's what I'm saying. What is the thickness what's the thickness of wing wall? What's the thickness of the slab of the foundation, the spread footing? What is the thickness of your slab? What's the thickness of the ballast wall? And then the other curtain wall, and what the thickness of the abutment. You indicate all of them here, and they are here. You can see they're all been given here. Then after you have done all that, there is the boundary conditions that you also need to look at. You find, I think in this case, we have used some spring constant. Spring constant. This is the plate for this is the foundation. This foundation is about 6 meter wide by I think 16 or 15 long. This reflects the width of the abutment and the deck. The deck is about 13 meters, and then when you look at the allowance of the wing wall and the foundation, so it could be about 16. So we simulated using spring constant. This spring constant represents the quotient of the stress to the quotient, or what it is that the subgrade reaction here is the bearing capacity or the soil pressure divided by the allowable settlement. So for spread footing, normally we have about 20 to 25, while for bearings about 10 to 12, I think, around there. But if you go to the manual and your literature, you should be able to get the right thing. So you have to know the subgrade reaction of this foundation. Once you get the soil pressure and you know the allowable deflection, you calculate. That's what you come and input into your input into the software, and then you're able to get that. The rigid connections also, those are boundary conditions. Is where you are trying to, if you are modeling your bearings, you have to link it to your if the top of slab is your basis, or where the measurements start from, that is now where you have to, from the top of the slab to the top of bearing, could be the rigid link. Then the elastic link will become between the top of the bearing and then the top of the abutment. So could be about 0.3 or 1/50 depending on the thickness. So you simulate that. So the stiffness of that should be similar to the stiffness of the actual bearing. So all these boundary conditions need to be put in place, and then now from there you go into the loading. You have to indicate self weight. You do temperature. Temperature loading is normally for the deck slab, but you will see that it also has implication all the way down to foundation. So you have to put all the loading. Once you are done with property of materials, section definitions, then boundary condition, then you move now to the loading. Once you have done your loading everything, including for the live load, vehicular load, all these things, the settlement, then you are able now to go to the next stage to do the analysis. That is what we need to do. So I think here you can see that the traffic here is basically we are using that's the lane number 2. You have lane number 3, then you have the lane number 1. So basically this one we adopted the Eurocode. Now once you have entered all this and everything is done, then you should be able now to do analysis. You just check that everything is in place and you do your analysis. Thank you.